Here we have another rate laws problem in kinetics, and we look at this reaction, which is a reaction of methyl bromide with hydroxide. Gives me methyl alcohol and a bromine ion. And so we're given some information. It says the rate law for this reaction is first order with methyl bromide and first order with hydroxide. And we got a set of concentrations here. One for the methyl bromide is 5 times 10 to the minus third molarity. And for the hydroxide concentration we have 0.05 molarity. And we're also told that the reaction rate at 298 is 0.0432 moles per second, and that's at that concentration, recalling that our reaction rate does depend on the concentrations. So first off, we want to know what is the value of the rate constant. So to get the value of the rate constant, we have to remember what does the rate law look like. And so the rate law is the rate times the rate constant times the concentrations raised to whatever order they are, and they're both first order, so that's to the first power. Okay, and all we have to do at this point is rearrange our equation and solve for the rate constant. This is what we're looking for. So the rate constant is equal to the rate at that particular concentration divided by the concentrations raised to their appropriate powers. And now all we can do is just plug in our values, and so our rate was given to us as 0.0432 moles per second. And we'll divide it by the concentrations that were also given to us. And plug it in our calculator, and we get 1.7 times 10 to the 2 per moles seconds. Now the second question is, what are the appropriate units? And it's really easy to do. This is in moles. This is in moles, molarity. Okay? And the rate is in moles per second. So first off, we're going to need a per second term. And we only need one of these moles, so we're going to have to divide by moles. And so if our rate constant is in units of per mole per second, then one of these moles will cancel and we'll be left with moles per second, which is what a rate is moles per second. So the appropriate units is moles, is a rate per mole second. So we answered what would be the appropriate units, and of course it was per mole per second. And so finally, with question C, what would happen to the rate if the concentration of OH minus was tripled? Well, recall that the rate is equal to the rate constant times the concentrations, both of them raised to the first power. And so it doesn't matter. This is to the third. This is tripled. It's to the first power. This is the same as saying 3 to the first, and that means the rate is going to be 3 times. So the rate is going to be tripled. That's what's going to happen. If we triple the OH concentration, we're going to triple the rate. If we triple the concentration of methyl bromide, we're going to triple the rate. Whatever it is. Finally, we're asked, well, what would happen if the concentration of both reactants were tripled? Well, if we triple the OH, we know we triple the rate, and if we triple the CH3Br, the methyl bromide, we're going to triple the rate, and so it's going to be 3 times 3, 3 to the first, times 3 to the first, and that's 9. So therefore, the rate is increased by a factor of 9 times 9. 3 to the first times 3 to the first times 9.